All right, this example is going to be one of the object motion questions where we have to analyze well, the question says to analyze and describe the motion of the object, but that gets pretty tedious because, um, as the object is moving back and forth and accelerating and decelerating and moving left and right and all that business, it gets pretty tedious. So I've changed the question from maybe what you have printed in front of you. The question is now when is the object left of the origin moving right and speeding up? Essentially, we have to do all the same things. We need to find the function for the velocity function and the function for the acceleration and do the analysis. Basically, a sign chart. So that's what we're going to do. First of all, it's really easy to find the three derivatives, right? The position function is just this one. The function that's given, that's the position. This will give me, depending on whether it's positive, negative, or zero, its position relative to some fixed point, the origin we think of it as. The first derivative gives me the velocity and whether it's moving to the left or to the right, right? We think of the distance changing in a positive way or a negative way. And it's an easy polynomial function. Make sure I didn't mess that up. Yeah, it looks okay. And then the second derivative was the acceleration. In fact, this is the first time we talked about a second derivative was when we did these motion questions because it had to do with acceleration. And now, we're going to analyze these functions to see when they're positive, negative, and zero. Where should we start? Let's start with the bottom one here. Why not? Because it's the easiest. So s prime at t equals 0 implies this 16 on the other side divided by 6, t equals 16 over 6 or 8/3. And so the idea is we're going to build like a sign chart, and this meant something when we were graphing functions too, right? Sketching functions rather, that when the second derivative is 0, usually we have a point of inflection. We weren't talking about that with respect to motion, and I'm going to hope right now that 8/3 goes right in the middle. And probably it'd be okay to collect up your sign chart at the end. And I know the second derivative is going to be 0 at 8/3. And notice I can also talk about where it's negative or positive, right? This is the second derivative. When it's more than that, like 4, 12, 17 over here, that the second derivative is going to be positive. What does that mean? Well, that means it's being pulled in the positive direction. It doesn't necessarily mean it's being speeded up, because if it's being pulled in the positive direction and the object is moving left, it actually means it's slowing down. So the fact that we know what the second derivative is, positive or negative, we don't know any of that part. But the first derivative, when it's 0, does give me some clues, and this actually factors, right? Could use the formula if you like, but it does factor. And then I get t equals 1/3 and t equals 5. So my first derivative is 0 at 1/3. I'm trying to give myself lots of room here. And 5 over there, so it's 0 here and here. Where are these things positive or negative? Well, remember, the first derivative is 0 is when the distance is not changing, or that means the object has stopped. When is the first derivative positive or negative? Well, notice that this is just a parabola. It's going to look like that. And so it's positive here, negative here, positive there. And so remember, positive and negative, the distance from the origin is increasing. So that means it's moving to the right. In here, it's moving to the left. In here, it's moving to the right. And so now if we want to have it moving right, it's got to be one of these pieces, right? Okay, well, let's keep going. When is the object to the left of the origin? Well, that's got to do with the position function. And when the position function is 0 is actually when a cubic is equal to 0. Oops. Well, what's that? How do we solve that? It doesn't factor. Well, remember, we could use the factor theorem. And oh, yeah, that's fun. Well, I'll tell you, I'll give you a little hint. When t equals 1, s at 1 is equal to 0, so t minus 1 is a factor. And then I'm going to use long division here. It's been a while, hasn't it? It's good to remember these skills. Plus 5t. Divide there. Minus t squared. And here we go with my not being able to get to the bottom of the screen. There we go. Let me just get a little more space. All right, some technical problems, but now I got a little more space. And then subtract. That says t squared, so I subtract that, and I get minus 7 here. Bring down the plus 5t. This is minus 7t here then. Minus 7t squared plus 7t. Subtract, and you get minus 2t. And this is going to work out splendidly. Splendid, splendid, splendid. And I will just tell you that this does not factor. So we're going to find the roots using the quadratic formula. Negative b plus or minus blah, 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 blah. Over 2 and is about equal to 7.3 and is about equal to negative 0.3. So that spots where the position function is 0 at negative, what did I say it was? Negative 0.3 and 7.3. And also at 1, where does 1 fit into this, right? Because we had 1 is a factor, that's a 0. Maybe I should write that down there. Oh, there we go. Pen's back. Oh boy. Also t equals 1. So I'm going to put that on my chart. T equals 1 right here. Between 1/3 and 8/3. 0 there. 0 here. 0 way out here. And this is a cubic. Starts low, ends high. So starts low, ends high. That's going to be negative, then positive, and then negative, and then positive. So where is it? Left of the origin. Left of the origin means that the function is negative, so anywhere in here or there. But moving right. Moving right means that the second derivative has to be positive. So here or here. Now notice that that sort of leaves us to this interval. And speeding up. When do I know it's speeding up? It's when the object is moving in the same direction as it is being pulled. And just we were lucky that in this interval here, all three of those things work. If this was minus, it could be that none of these, that nowhere on our interval was this actually true, but it was. So for this situation, the object met the criteria. And funky pen again. Great. I was hoping it would hold off. Look at that answer. The answer was between 5 seconds and 7.3 seconds. That's when it was left of the origin, moving right, and speeding up because it was also being pulled right. So between 5.3 seconds and 7 seconds. And I do have my met the criteria between 5 seconds and 7.3 seconds. Okay, thanks for being patient with the wonky wandering pen.